Sand is the single most consumed natural resource on Earth after water. Every year, humanity uses over 50 billion tons of sand, enough to build a wall 27 meters high and 27 meters wide all the way around the planet. Sand. At first glance, it seems so ordinary, so plentiful, so insignificant. After all, it's just tiny grains of rock scattered across beaches, deserts, and riverbeds. But how do we actually harvest this vast quantity of sand? What does supergiant sand mining look like, and what secrets does it hold? In this video, we'll take you inside the billion-dollar industry that extracts, processes, and transports unimaginable amounts of sand every year. You'll discover how sand is mined from rivers, quarries, and seabeds, how it's sorted, washed, and transformed into essential building blocks of our lives, and why this seemingly abundant resource is becoming one of the most contested commodities in the world. Before we dive in, make sure to like, subscribe, and hit the notification bell so you never miss our behind-the-scenes deep dives into the industries that shape our world. Now, let's uncover the billion-dollar secret of sand. Not all sand is usable. Desert sand, for example, is too smooth and rounded from wind erosion. Construction requires angular sand grains that lock together like puzzle pieces. That's why most of the sand we use comes from rivers, lakes, and coastal deposits, where water action creates sharp, durable grains. As demand skyrockets, sand has become a multi-billion-dollar global commodity. Some analysts even call it the new oil. And like oil, its extraction is reshaping landscapes, economies, and even geopolitics. This is where the action begins. Dredging. Imagine a vacuum cleaner the size of a small ship. Suction dredges pump up sand mixed with water from the riverbed, sending it through pipelines that can stretch for miles. Some dredgers pull in over 10,000 cubic meters of material per day. Excavation. In open-pit mines, colossal excavators scoop tons of sand into dump trucks or conveyor belts with each movement. A single truck can haul up to 40 tons per trip. Frac sand mining. In states like Wisconsin, sandstone layers are blasted apart. The rock is then crushed to release the high-purity silica grains used in hydraulic fracturing for oil and gas. In total, the United States alone produces over 110 million tons of industrial sand and gravel every year. Raw sand is a dirty business. It's mixed with clay, silt, and organic matter. That's why the next step is cleaning. At giant processing plants, vibrating screens shake the material, sorting grains by size. Then, powerful jets of water wash away mud and impurities. For specialized silica, advanced processes like flotation and magnetic separation remove unwanted minerals such as iron or feldspar. This ensures the sand can meet strict industry standards, whether for strong concrete, crystal-clear glass, or delicate electronics. Once clean, the sand either goes straight to construction or enters another phase of refinement. Rotary kilns dry the material at scorching temperatures, sometimes exceeding 1,000 degrees Fahrenheit, 538 degrees Celsius. Frac sand is graded into exact grain sizes, each engineered to survive the extreme pressures deep underground in oil and gas wells. Meanwhile, silica sand destined for solar panels and microchips is purified until it reaches an astonishing 99.9% silica purity. This is the hidden backbone of high-tech America. Here's where scale becomes mind-blowing. Sand is heavy. Just 1 cubic yard can weigh about 1.3 tons. Moving millions of tons requires some of the biggest logistics systems in the world. In the Midwest, unit trains, stretching nearly 2 kilometers long, transport frac sand, with each train carrying more than 10,000 tons. On the Mississippi River, barges haul sand downstream, sometimes with 70 barges linked together, moving enough material to fill a football stadium. And internationally, cargo ships transport silica sand to glass factories and chip makers across the globe. Mining always leaves a mark on the land, but in the US, companies are required to restore the environment. Once sand is exhausted, pits are filled with water to create lakes, wetlands, or reservoirs. Others are converted back into farmland or even parks. What once looked like a scar on the earth can eventually become a haven for wildlife and communities. On the surface, sand seems infinite, but giant mining operations are exposing a troubling reality. Sand is a finite resource. In some regions, over-extraction has caused rivers to shrink, groundwater to vanish, and coastlines to erode. Fish populations collapse when their spawning grounds are disturbed, and communities lose farmland as riverbanks cave in. The rising demand has even fueled a black market for sand. In countries like India, sand mafias illegally mine riverbeds at night, clashing with locals and authorities. Environmentalists warn that unregulated mining could create shortages within decades. The irony is clear. While deserts hold endless sand, most of it is unusable for construction, making sharp river sand more precious than gold. At the same time, recycling efforts are growing. Crushed concrete, glass, and even manufactured sand from crushed rocks are being explored as alternatives. But for now, natural sand remains king. The future of sand mining depends on balancing demand with sustainability. Some countries are introducing strict regulations, requiring miners to restore landscapes after extraction or banning river mining altogether. Technological innovations, like producing artificial sand from basalt or granite, offer hope for reducing pressure on natural sources. Meanwhile, researchers are developing new building materials that require less sand or none at all. For example, green concrete mixes industrial byproducts like fly ash with reduced amounts of sand. But one fact remains. As urban populations grow and megacities expand, the demand for sand will only rise. By 2050, the world's urban population will increase by 2.5 billion people. That means more houses, more roads, more glass, and much more sand. Sand, the most ordinary material beneath our feet, is in fact the invisible foundation of our world. Every skyscraper, every highway, every smartphone screen owes its existence to billions of tiny grains mined from rivers, lakes, and seas. Supergiant sand mining is a billion-dollar industry, moving mountains of material each year to feed our insatiable appetite for growth and technology. But it also comes with costs. Eroded landscapes, threatened ecosystems, and rising conflicts over who controls this vital resource. As we look to the future, the story of sand is really the story of humanity itself, a story of innovation, consumption, and the urgent need to build sustainably. If you found this journey into the supergiant world of sand mining fascinating, don't forget to hit like, subscribe, and turn on the notification bell. That way, you'll never miss our next deep dive into the industries that shape our lives. Thanks for watching, and remember, sometimes the smallest things make the biggest difference. Paper is one of humanity's greatest inventions. It carries our thoughts, preserves history, enables education, and even wraps our food. From the ancient scrolls of China to the printing of millions of newspapers every single day, paper has shaped civilizations. But behind every sheet of paper lies a fascinating journey. A journey that begins in the forest, travels through mega factories with machines hundreds of meters long, passes through the roaring engines of printing presses, and often returns again to the cycle of recycling plants to start its life anew. So let's unfold the story, sheet by sheet, of one of the most important materials in human history: paper. Before we dive into the fascinating journey of paper, I'd like to invite you to join our community here on YouTube. If you enjoy learning about how everyday things are made and discovering the hidden stories behind them, make sure to hit the subscribe button and turn on the notification bell. That way, you'll never miss our future videos. Our story begins deep inside managed forests. Contrary to what many think, most paper does not come from old-growth forests, but from sustainable tree farms. These are carefully planted and harvested areas designed to balance industry needs with environmental protection. Workers select trees, mostly softwoods like pine and spruce, or hardwoods like birch and eucalyptus, because of their strong, fibrous structure. Once cut, the logs are stripped of bark, chipped into small pieces, and transported to massive pulp mills. Here begins the transformation. Wood is made of three key components: cellulose fibers, the building blocks of paper; lignin, which binds the fibers together; and hemicellulose. To make paper, we need to extract the cellulose. The chips are cooked under high pressure with chemicals in giant digesters. This process, called the Kraft process, dissolves the lignin and separates the cellulose fibers. What's left behind is a brown, mushy mixture called pulp. But raw pulp isn't yet ready to become paper. It needs cleaning, bleaching, and refining. Impurities like knots, sand, or leftover lignin are removed. Then bleaching agents are used to brighten the pulp, giving us the clean white fibers needed for high-quality printing and writing papers. The pulp is then mixed with water, lots of it. In fact, the pulp slurry at this stage is 99% water and only 1% fiber. Why so watery? Because it allows the fibers to flow evenly onto screens in the next stage, forming consistent sheets. This is the foundation. From towering trees, through chipping, pulping, and bleaching, we now have a raw material ready to be shaped into paper. Now comes the mesmerizing part, turning pulp into continuous rolls of paper. The diluted pulp mixture flows onto a moving wire mesh conveyor called the Fourdrinier machine. As water drains away, the fibers begin interlocking, forming a wet mat. Giant suction boxes pull even more water out, and slowly, a sheet of paper starts to take shape. Next, the damp sheet passes through enormous heated rollers. These squeeze out the remaining water while drying the paper under controlled heat and pressure. It's a delicate balance. Too much pressure and the sheet becomes brittle. Too little and it won't hold its form. After drying, the paper undergoes calendaring, a process where smooth steel rollers compress it to achieve the desired thickness and surface texture. This is how we get glossy magazine paper, crisp office paper, or rough cardboard, all from the same pulp, just processed differently. Finally, the finished sheets are wound into gigantic rolls, sometimes weighing up to 30 tons and stretching for miles if unrolled. These rolls are then shipped worldwide to publishers, packaging companies, and printers. At this point, paper is a blank canvas, ready to carry the next big idea. The invention of the printing press in the 15th century turned paper from a luxury into a necessity. Today, modern printing presses run at lightning speed, producing newspapers, magazines, books, and packaging on a massive scale. In offset printing, for example, inked images are transferred from a metal plate to a rubber blanket, then pressed onto paper. The paper zooms through rollers at hundreds of feet per second, each sheet absorbing precise layers of ink. Think about it. That morning newspaper you hold was just a blank roll of paper the day before. Now it's filled with photographs, headlines, and stories, brought to life by printing technology. From political revolutions to love letters, from textbooks to advertising posters, printing on paper has been humanity's way of spreading knowledge, culture, and emotion for centuries. Unlike many materials, paper can be recycled up to 5 to 7 times before the fibers become too short to bind. Recycling plants collect used newspapers, cardboard boxes, office waste, and packaging. The paper is sorted, shredded, and mixed with water to form a slurry again. Ink is removed through a process called de-inking, where air bubbles lift ink particles to the surface. The cleaned pulp is then mixed with fresh fibers for strength. This recycled pulp goes back to paper machines, forming new sheets. Some become newspapers again, others packaging boxes or even tissues. Recycling not only saves trees, but also reduces landfill waste and conserves energy. Each ton of recycled paper saves about 17 trees, 7,000 gallons of water, and enough energy to power a home for 6 months. If you enjoyed this video and want to see more fascinating journeys of everyday materials, don't forget to like, subscribe, and hit the bell icon. It really helps us grow and bring you more educational content from inside the world's most essential industries. Thank you for watching, and remember, the story of paper is also the story of us. How does a lump of soap, sitting quietly on your bathroom sink, go from raw ingredients to the tool that keeps you healthy, fresh, and ready for life? Well, today we're taking a trip inside an American soap factory, where tradition meets technology, and where every bar, every drop, has a story. Before we dive into the bubbly world of soap making, I've got a quick favor to ask. If you love learning how everyday things are made right here in America, hit that subscribe button and tap the bell. That way, you won't miss any of our behind-the-scenes adventures. And trust me, they smell a lot better than this one might at the start. Alright, let's get our hands sudsy. Soap is older than the United States itself. Thousands of years ago, people discovered that if you mixed animal fat with ashes from a fire, you could make something that actually lifted dirt and grease right off your skin. When the first settlers came to America, they didn't have fancy pumps or factory lines. Soap was made at home, in backyards, kitchens, and barns. They'd save animal fat from cooking, boil it with lye made from wood ash, and pour it into wooden molds. It was rough, harsh on the skin, but it worked, and it was precious. Fast forward to today, the chemistry is the same. Soap works by surrounding dirt and oils, locking them in tiny bubbles, and carrying them away with water. But the way we make it? That's where modern American factories take the stage. Let's step inside one in Cincinnati, Ohio, a city that's been called the birthplace of some of America's biggest soap brands. The moment you walk in, you notice the smell. Not overpowering, but soft and layered. Hints of lavender, citrus, maybe even vanilla. Somewhere in here, a batch of fresh linen is being bottled, and across the hall, giant vats of bar soap are cooling into perfect blocks. The place is alive. Stainless steel mixing tanks hum quietly. Conveyor belts glide past, carrying rows of bars. Workers in clean uniforms check gauges, take samples, and keep the rhythm moving. This is soap making at American scale, but with the same care you'd find in someone's kitchen, just multiplied thousands of times over. Soap may seem simple, but it starts with a carefully chosen mix of fats or oils and an alkali, usually sodium hydroxide known as lye. In this facility, huge tanks hold natural oils like coconut, olive, and palm, each adding its own personality to the final product. Coconut oil makes the soap bubbly and light, olive oil gives it a creamy lather, and palm oil adds firmness so the bar lasts longer. These ingredients arrive in big drums, labeled and checked for quality. Workers in safety gear take samples, making sure every oil is pure, clean, and exactly what the recipe calls for. This is where science meets craftsmanship.